Hey there, I'm NASA astronaut Ricky Arnold. Welcome aboard the International Space Station. Today we're going to talk about the Space Station truss. The truss segment is just about 100 meters from side to side.
A truss is a segment or part of the whole integrated truss structure. The trusses are used to support the 16 solar array panels, which provide energy for us, and radiators which get rid of excess heat that builds up inside the space station. The design of the truss involves triangles and beams, which can be seen on Earth in structures like bridges. Why triangles? Well, this is because of their unique geometric properties, their methods of transferring loads, and their spatial openness. Triangles are more rigid than rectangular shapes because they have fewer joints. The larger number of joints in a shape, the more prone that shape is to being impacted by shear forces.
What I'd like to talk a little bit about today is some of the forces that can act upon the truss. Well, the first force I want to talk about is compression force. And compression force is just like it sounds, two things coming together. So if we apply a compression force to the truss, what do you think is going to happen? Well, let me go ahead and do it. And you can see right here where the truss would bend. What do you think the opposite force of compression is? Yeah, it's right. It's going to be pulling apart. We call that a tension force. And a tension force is what's going to help maybe even rigidize the truss segment, but it also could potentially pull it apart. I'm not going to pull apart this tape measure because we probably need it later for some work we have to do.
Now, if you look carefully, this next force I want to talk about
is basically kind of like a twisting force, and we call it torsion. And even when I just let go of the tape measure, you can see it will actually start to happen a little bit. You can start to see, because the center of mass is actually right here, where most of the tape measure is located, and when I let it go, the tape measure itself starts to twist just a little bit. Finally, the fourth force
that can act along a truss segment
is that can occur at a single point where two opposing forces work on a single point along the truss, just like they can upon the Earth's surface. Think about some earthquakes. You can have a plate that is, or along a fault line, where one side of the fault line is moving upward or being forced upward, while the other side is moving downward. And that force in one point in opposite directions is called a shear force. And we can also have that happen on the truss segment. Something like this.
One thing to think about, where do these forces come from?
One force, even though we're up here largely out of the Earth's atmosphere, we do still have drag with the Earth's atmosphere, which can impart loads on or impart a force on the truss segment. Another, I already hinted at earlier, is crew working inside. We're up here, we're exercising, we're moving really heavy pieces of equipment around. So we have an amazing engineering team on the ground, and we have specific disciplines that their job is to monitor all the forces imparted upon the International Space Station. They keep track of all those various forces I talked about and where they could be coming from, the atmosphere, visiting vehicles, or even things that the crew are doing inside the space station, and to make sure that those forces aren't significant enough to cause any damage to this wonderful laboratory and living space we have up here in low Earth orbit. Thanks so much for joining me today. We'll see you next time. So long.